Hi and welcome to our today demo, which is about OpenSwitch. OpenSwitch is a network operating system which can be installed and deployed on bare metal or disaggregated network switches. It has a hardware compatibility list. It is not compatible with all the switches. It is compatible with certain type of switches which are listed in the OpenSwitch HCL. Mostly they are Dell EMC, and also some type of EdgeCore switches are also supported to run the OpenSwitch network operating system. OpenSwitch, I think it was started a few years ago. Mainly, I think it was with participation with HP. And during that time, the initial generation of OpenSwitch was mainly it was based on some kind of traditional network operating system. So when you could install that operating system on the network switch, like one of these bare metal switch, but after the boot up of the switch, you could see a very familiar user interface, like a CLI of industry standard CLI, with commands like config T, config terminal, or doing the IP configuration, or everything through one single CLI. That was the approach, the initial approach of the OpenSwitch. I think I don't know exactly when it happened, but a revolution completely happened to OpenSwitch, and they made it very, very, very wide and flexible. So the approach got changed. They started rebuilding the OpenSwitch with OPX. I think with mainly some development resources from other participators within the project. I think a lot of efforts also from Dell EMC. And the new operating system is it's just it's a Debian Linux based on the Debian Linux, and it includes the switch abstraction interface and other networking services and APIs. And each piece of software, each piece of routing or bridging, they are all running as a separate piece within this operating system. So it's a complete modular kind of operating system, designed and built for disaggregated network switches. If you are familiar with Cumulus Linux, to me, they use the same type of approach. So Cumulus Linux also is based on one pure Linux-based operating system with additional components of the routing, switching, and other piece of softwares. In OPX also you see the same kind of method, but in general, I think Cumulus is more mature right now in terms of software. So let's have a look. Let's start with how we can do a demo with OpenSwitch. So if we browse to openswitch.net, from here we can start from the wiki page. So if I click on the start from wiki, here it gives us some information, and also there is an option here to run the OPX in a virtual machine, which is good, and everyone can do a touch base with OPX from here. So let's try with doing it with the virtual machine. So the virtual environment for OPX, the one which has been created and provided by OpenSwitch folks, is a virtual machine which is executing a Dell S6000 ON device. S6000 is a 32 port 40 gigabit per second switch. So 32 port 40 gig ports. It's a switch, so it's a virtual machine which simulates actually the same hardware. So to run this, you can run it on any platform. It supports Windows and Mac, and as well as Linux. We just need VirtualBox. So I have downloaded and installed already VirtualBox. I have the latest version of the VirtualBox running on my machine. And to install that, either we can use the tools like LVM or VM.exe, which is for creating the virtual environment of OPX. But there is a simple way for doing that. You can use Vagrant as well. So if we go to here, the OPX releases are available on Vagrant. So let's try and access this through the Vagrant. So in Vagrant, I will search here. I will choose VirtualBox as my platform, and I will search OPX. And here, these are all the official versions, and the latest version which is available here is the version 3 300. So this one. And to install and deploy this, you just need to have Vagrant installed on your machine, and that's it. You know, this is all we need to do. So I will copy these commands: Vagrant init OPX /300, box version 300, and Vagrant up. Let me open a command prompt here, and if I put this command here, and here we go, the Vagrant will start downloading the OPX from the Vagrant cloud. And so what will happen is, you know, someone from OPX, they have already created these virtual machines. They have uploaded this to the Vagrant, and with this command, I download that image from the Vagrant, and it loads it on my VirtualBox. So let me accelerate this part, and after this, you will see my VirtualBox will have a new virtual machine called OPX. Okay, so now you can see a new virtual machine has been created here, and it's running. And if I click here on the show here, now I get the console of OPX 300 VM login. The default username is admin, and default password is also admin. So now we got the shell access to our new OPX OpenSwitch box. So the first thing I would do is to bring up a management interface, and we set up an SSH access, because using this console is really painful. So first, let's see what is the network connectivity to this virtual machine quickly. So here in my host network manager, I have a virtual network within this host, which is in this network 192.168.56.1, and my host is also running a DHCP server. So I need to make sure whatever interface I'm connecting to this virtual machine, to our OPX, it's connected to the VBox net. So let's check what's going on here. So this is the configuration of this virtual machine. We go to network, and so we got the network adapter, and that network is connected to NAT. I want to change that to not internal, host only network, and VBox net 0, which is the one which we have there. And here we go. Okay, so now it's connected to the correct network interface. Let me do an ifconfig here to see what are the interfaces. We have to do with sudo admin. Okay, so we got Ethernet 0, which has 10.0.2.15 IP address, which I think is not correct. Let me change the set the static IP also on that interface. So so this is a Debian machine, so we can use the /etc network interfaces for changing the Ethernet 0. So Ethernet 0 is in a DHCP, we say static, and we say address 192.168.86. let's say 10. Net mask should be 255.255.255.0, and gateway is 192.168.50.86. Yeah, sorry, it is 56.1, and I will change this also back to 56. This line actually is not required, so I mark that, and we save this file and exit. Let me do again a networking restart. Let me flush this IP address, maybe flush Ethernet 0, and let's do networking restart. Okay, so it got the correct IP address now on the interface. Now let's try to do the SSH to this machine. So from our shell, from our console here. So we do SSH as admin at 192.168.56.10. Yes, and Should ask her for the password. Yep. So now we got the SSH access. So we don't need the console anymore. So we are free finally. Okay. So now we got the shell access to the OPX. So this is like a imagine that, you know, we got the switch, one of these S6000 Dell switches, and this is the login access to this device. So let's start doing some practice and see. So as you see, this is a Linux shell. So one important thing which you should know is that whatever we do here in this shell, specific commands, they will get translated and injected inside the switch ASIC hardware, that chipset. So changing, creating, removing VLANs, enabling or disabling spanning tree here, you know, running the routing protocol, modifying the routing table will have an impact that switch abstraction interface or those drivers that are loading inside this virtual machine, not exactly on this virtual machine, but in the real OpenSwitch. It always monitors that, for example, the routing table, or whenever we add any commands for adding, removing the VLANs and stuff, they take those output and they inject them as specific API calls to the switch chipset. So all of them will get, so whatever we do here, it gets injected inside the switch silicon. So this is like a user interface to the switch silicon that we have. Okay. Let me go back to the website of OPX. In the OPX, we can start also, if you look at the software downloads here. So we downloaded actually the Vagrant file, that VM part, but here there are different installers. So if we go for example, version 310, these are the installers. So this is the Dell EMC installers for 310. This is the version, and you know there are different versions also available. You know, it has also some available versions for EdgeCore as well. So for example, version 210. It supports Dell EMC switches. Also, it supports specific switches from EdgeCore. I think AS5712 probably. Don't remember exactly. Now here in and they got also documentation here. So let's say for example in 300. We got documentation, the administration guide, you can see configuration guide, development guide, and installation guide. So you know it's a pretty much fine documentations. You know, it will help you, you know, to understand how the OpenSwitch works. So these are the documentation of the switch. Now let's go back and do some basic commands with OpenSwitch and see how it works. All right, so let's start with looking at the physical ports. So if we go in /etc, there is a folder called OPX, and here we got these are most of the configuration files of OPX, which are all located here. And this file here, this XML file, base port physical mapping, this one, it explains the mapping of these logical ports here in the operating system to the real physical ports in the switch. So if let's do a nano of this base port. So this XML file, as you can see, here there are we have these tags: front panel port number. So port number 1 is called E101-001-0. So this particular port, this particular name is a logical name in the operating system here that we can deal with. So port number 1 actually is named as this name, and it's connected to 1, 2, 3, 4, these 4 hardware ports. Actually, these 4 hardware ports, they are all one. So this switch, as you remember, you know, it's a S6000 switch, which is a 32 port 40 gigabit per second switch. So each port is a 40 gig port. So if you use it in this model, so this one, you know, the port number E101-001, it becomes a 40 gigabit per second port. We can divide this port into 4 10 gig ports. So that is there are some breakout cables that you can use, and you can break a 40 gigabit per second port into 4 10 gigabit per second port. So this is for that, it's a kind of fan out. So you can use this configuration if we can divide this, to have, one single port and only one single hardware port, port number 25. So we can divide the 40 gigabit per second port into 4 10 gigabit per second port. So this is how the mapping is happening. So each port number, actually these are all logical port numbers that we can deal with. So we will use these port numbers when we are creating VLAN interfaces or assigning IP address to these interfaces. But this is how the mapping between the hardware ports and the ports here in the operating system works. Let's have a look at the processes running as OPX. Let's only filter the OPX process. So we got the OPX CPS services, PAA services, NAS daemon services. These are all services running from the OPX in the machine. So each service has different functions. Even if we do systemctl grep OPX, these are all the services loaded from the OPX. Okay, to manage the OPX itself, we got some OPX commands, which are starting with OPX dash. So let's say OPX show environment. So if I show environment, I think I have to do it with sudo. So this command shows us the status of the switch, the operation status of the chassis failed, because this is a virtual machine, so it's not able to get the real information, and these are just virtualized. The power supplies, the fans, so we got 4 fans, and the temperature sensors. Let's see the other commands, like OPX show alarm. So if there is any alarms, it can give us some information. So right now we don't have any alarms. Or show packages. OPX show packages. So this one shows all the packages, the OPX piece of software. So this can be used to understand what current software libraries of the OPX is being run, or if we need to upgrade any of these packages. And we got show transceivers, for example. Show transceivers in sudo. Summary. So this command shows the virtualized 32 QSFP plus 40 gigs with serial number and part number, but in real world it will show you all the transceiver information. So actually this command, it goes and talks to the CPLDs and gets the information of the SFPs. It reads the EPROM from the SFPs. And also let's try OPX show version. So this command gives us information about what is the current version we are running, what's the platform, and the basic information of that. So let's do some layer 2 testing now with OpenSwitch. See how the layer 2 configuration will go. All right, so let's start with let's clear the interface. Let's start with creating a VLAN and putting few ports inside the VLAN. So for doing that, we will use the command called bridgectl. So bridgectl is the Linux bridge controller. It is very similar to what we do in the OVS. It's also creates these virtual bridges or virtual switches. Now we use this command to communicate with kernel for creating this VLANs. So let's create a new VLAN or bridge called for VLAN 100, for example, and we say add bridge 100. So I have to do a sudo. Okay, and if I do a bridge control show, it shows me the list of bridges or virtual switches or the VLAN. So we created a new VLAN called VLAN 100. Now we have to assign this VLAN interface to that. So we can assign a tagged interface or an untagged interface to this new VLAN which we have created. So let's assign. Let's start with a tag interface. So let's create a tag interface. We use the IP link add link. Let's use the Ethernet 101.001-0. So that's what one of our physical interfaces. So within that physical interface, it will say create a new one called E101-001-0.100. So the 100 is a sub interface within that physical interface for that VLAN. Type VLAN, so it's a VLAN interface with the ID of 100, and I have to do a sudo. Okay, so we have created a tag interface. So we just created a tag interface. We created a sub interface right now. We haven't added to the bridge now yet. Now we will say bridge CTL. I want to do bridge CTL add interface on which interface? So I want to add the interface on the bridge 100, which we have created earlier. Now what is the interface name that we are going to add? Is the new tag interface name which we created, E101-001-0.100 sudo. Now if I do a bridge CTL show, you can see that the bridge 100, it got the new interface called E101.001-0.100. So if we connect a cable to the Ethernet port 1, that 40 gigabit per second port, we connect a cable to that and we connect it to another device. Right now it has a sub interface of 100, which means that that port is a trunk interface, or it can send .1Q trunk, .1Q frames, and it will be sending. It can send the traffic for this particular VLAN. So it will be able to send frames with .1Q header with VLAN ID of 100. Now let's add another port to the same bridge, to the same VLAN, an untagged port. Let's say on the port number 2. So if I do same command, actually, if we add the port number 2, and now we got two interfaces. So we got port number 1, VLAN 100, and the full port number 2 untagged ports, is all in the same. So if you connect two devices, let's say to these two ports, to port number 1 and port number 2, on port number 1, if you have another device which is capable of sending .1Q frames with VLAN ID of 100, it will be able to communicate with the device which is connected to port 2 on our switch here. So this is how we created the VLAN 100, and we assigned two interfaces, one tag interface and one untag interface to our VLAN 100 here. Now if you look here, the spanning tree is disabled. It's not enabled here. Let's enable the spanning tree here. So we call bridge CTL on STP spanning tree for bridge 100 on, sudo. And if I do again show, now it shows the spanning tree is enabled. So we got spanning tree running. Now to get the more details of what spanning tree we are running, we will use bridge CTL show STP of bridge 100, and we get all the details. So our bridge ID and the root ID for that switch, or the port ID, the designated port, root ports, all the information will be shown here. So the full spanning tree is running, And so when we enable the spanning tree here, what will happen is, it will call again to the hardware API for enabling the accelerated spanning tree on the if we got a hardware based. For you can do also use the LLDP CDI. So LLDP CLI is a command also for we can use it for show the, which right now we don't have any LLDP neighbors. So this is another command that probably we will know within layer 2 that how to use how to find our neighbors. Now let's do some checking on the routing and how we can enable routing protocols on OpenSwitch. Okay, so to deal with the routing, it's again basic Linux command like IP route show. So right now we have a default gateway 192.168.56.1 on Ethernet 0, which is actually our management interface. We can do adding static routes. So IP route at, let's say, 5.5.5.5/32 via 192.168.56.1. And if I do again show IP routes, so now it shows 55555 is via this, right? It doesn't make sense because our default route actually is pointing the same, but this is just how shows you how you can create a static route using the Linux IP route commands. To show the IP addresses of the machine also, we can use IP address show. So this shows all the interfaces, and if any interface has got any IP address, it will show the IP address for that interface. So right now only our Ethernet 0 has got an interface. That's the only thing we have. Nothing on the other interfaces. Okay, now let's see how we can do the routing. For doing the dynamic routing, running our BGP, OSPF, and other routing protocols, in OpenSwitch also uses FRR. So FRR is like a standard package for routing in Linux, and also for these switches which we have. So for doing that, if I can show you here, and show you here that in the configuration guide of OpenSwitch. So for doing the routing also, it suggests that we have to install the FRR routing. So again, the same familiar picture that Zebra communicates as a broker with other routing daemons, and for installation we can use the apt-get install, but we have to download the package. So let's download the package from the FRR. So in the FRR website, we go on download, release, and here we go. So we got all of these packages. What we need a Debian package, FRR6, Debian. These are all debugs, debug, devel. There we go. FRR601 Debian 9+1 AMD64. So this is the file which we need. So let's copy the link location, and here we'll download this file. wget this. I think I don't have any DNS server. Sudo nano /gpc/ That's the easy way to do that, and here we go, we can download that. Okay, so by the way, the reason that this virtual machine is able to communicate to the internet is that on my device I have created a netting for between the virtual interface which this device is connected, I mean the virtual box is connected, and my wireless connection. So on my laptop, because this is a laptop running the virtual box, so I have used the IP tables for doing the netting between these two interfaces. That's how this machine is able to access the internet. So we got the FRR downloaded, and we'll do apt apt-get install /frr and sudo. Okay, so sudo, it will download. So installing it with apt-get, it downloads, then installs the dependencies. So it looks like it's installed now. And now, first things first, we need to enable the Zebra and the other daemons which we need. So nano /etc frr daemons. Here we go. So Zebra, we enable Zebra, and let's enable the BGP also. So we have all the other routing daemons, and we don't need any of them. Save this, and systemctl, we can enable frr, and we will restart or start frr. Now we should have access to v2ysh. Yeah, so we got access to the v2ysh. This is our routing, and it shows all the interfaces, and from here we can also do the configuration of router BGP 65000, for example, and can configure some neighbors. 65,000. Right, ma'am. Yeah, so here I don't have actually any device connected to this, but we could establish some BGP neighborship with another device probably. And if we exit from here, all of these configurations are saved inside our BGP daemon. And so when the Zebra is running and all of these other routing daemons are running, whatever happens, the other daemons, for example, the BGP daemon communicates with other BGP neighbors. It downloads it receives the BGP prefixes from the others, and it chooses which one is the correct prefix that has to get installed in the routing table. And it will get delivered or handed over to Zebra, so Zebra will deal with the routing table. Now here we got a piece of the OPS which gets those, whatever changes are happening in the routing table, it injects those route inside the real switch, the hardware routing table. So that's how the switch operates. So we have the Linux shell, the Linux, and all of these software components that are running. Whatever happens in the routing table and other pieces, other parts, like whenever we create this bridge, with bridge CTL command, or we assign IP address, all of those commands will get injected inside inside the ASIC, inside the switch hardware. So I suggest also, if you get some time, you can try also Cumulus Linux. They got also a testing machine, and Cumulus Linux is very similar to this, but they got a command called net. So it's with the net command you can do everything with one single command. So net, you can configure IP addresses, you can configure your routing, you can do almost everything with one single command. So initially Cumulus also was like this, but now it's much more matured, and it has many of these type of additional tools to make the life much easier when we are working on this open networking and disaggregated switches. Now, one of the best things of this type of operating systems is that it's just pure Linux, so you can install your Puppet agent or anything else, your choice of the DevOps or automation tools, and you can just manage everything through the through a DevOps tool. So any changes on the IP addresses, or a configuration, a dynamic kind of configuration that it changes based on the application requirement, all of this stuff can be implemented using the automation tools. So it's very, very flexible and automation friendly type of operating system, unlike the other traditional operating system. So this was about our OpenSwitch. Unfortunately, I didn't have a compatible hardware, so the hardware which I have is not compatible with OpenSwitch. It doesn't work, But you know, it's a good choice to use the a virtual machine and do everything on the virtual machine and test. You can also try it with your VirtualBox and operating and load the OpenSwitch operating system. If you have any question, please feel free to raise in the forum, or you can contact me directly. Thank you very much.